So in this video, I'm going to introduce you to a second type of finite state machine, one that's a little bit different than the finite state machines we've been looking at so far. But before I do, I'd like to remind you of our high-level finite state machine diagram that we've seen a few times now, right? That says, the next state that we're going into is dependent on the current state as well as our inputs. That next state information gets stored into a flip-flop or a register, for example, and then we can determine our output depending on what state we are currently in. Up until this point, we've been ignoring this part of the diagram, which says we can also have some asynchronous outputs. And if we look at this diagram, we can see that our asynchronous outputs depend on what state we are currently in, as well as the values of our inputs. So that is the kind of finite state machine I would like to talk to you about in this particular video. Here is an example of the same finite state machine that we saw a few videos ago for the fair arbiter circuit. But this time it looks a little bit different. You'll notice that instead of seeing the outputs inside of the individual states, the outputs are now listed on the transitions. So we see outputs here listed on the transitions instead of the states. This finite state machine will actually lead to an equivalent circuit in terms of functionality as the original finite state machine that we saw a few videos back. But since the outputs are now dependent on the inputs and not just what state we are in, this is what we call a Mealy machine. Right? The original finite state machine that we saw is called a Moore machine, M-O-O-R-E. So if you see outputs, right, in the states, you know right away that there is a Moore machine. It's a Moore finite state machine. If you see outputs on the transitions instead, you know right away that it is a Mealy machine instead. So you should definitely take a look at this Mealy machine and convince yourself, right, that it actually is in fact equivalent to the Moore version of this machine that we saw before. The way that we interpret this, right, if I start at this particular state and I see my inputs are 1 and then I don't care what the second input is, that means my outputs are going to be 1, 0. But I could also take this transition instead. If I see my inputs are 0, 1, right, the outputs will then be 0, 1, which is different than what I saw over here. So my outputs now depend on not just what state I'm in, but also the inputs that I'm getting as well. So we are defining our outputs as being asynchronous in this particular case. That is the definition of a Mealy machine. A Mealy machine is a finite state machine that has asynchronous outputs. A Moore machine is a finite state machine that uses only synchronous outputs. So at this point, you know just about all we need to know to start using finite state machines and designing circuits using finite state machines. We just have one more video that's going to kind of wrap up some concepts.